All right, in question 4, probably the wordiest of the questions. This is talking about a true fact. A person called Fred Rumpelberg, who's from the Netherlands, rode his bicycle across the Bonneville salt flats at a very high speed, 270 kilometers per hour almost, with a vehicle in front of him which blocked all or almost all of the air resistance. And at the time, the fastest that anybody was able to ride a bicycle with air resistance was 71.3 kilometers per hour. So if that vehicle in front of Fred suddenly stopped blocking the drag force on Fred would be enormous and would be pushing backward on Fred. How many times larger would the drag force acting on him be than the frictional force of his tires on the road? So Fred is pedaling forward to try to go as fast as he can. We're asked to assume that he could pedal as hard as the person who set the world cycling record. And remember that inertial drag grows in proportion to the square of the speed. So we have the clue that we want to use proportional reasoning in this problem. And we're given two speeds. We know that drag goes as the square of the speeds, so we probably suspect that somehow we're going to take the ratio of these two speeds and square them. But let's come up with a rationale for why we're going to do that. So the world cycling record was somebody who was pedaling as fast as they could against drag. So if we draw a free body diagram for this cyclist, for the cycling record, this person will have a weight. They will have a normal force that's equal to their weight if they're pedaling on the level. And as they pedal, they're causing their tires to turn. Their tires are acting on the road and propelling them forward as hard as they can with a frictional force, but they're going at a constant speed of 71.3 kilometers per hour, which means that there's an equal and opposite force acting backwards on them, which we're told is the drag force. And so for the cycling record, we would expect that the size of the frictional force that they're exerting, or that is being exerted by the tires on the road because of how hard they're pedaling, is going to be equal to the drag force at 71.3 kilometers per hour. And the net force in this problem is equal to 0. Now, Fred, on the other hand, was going really fast. And we're saying the vehicle in front suddenly stopped blocking drag. Well, if the vehicle in front stops blocking drag, and Fred is still pedaling as hard as this earlier person, so if they're pedaling as hard as the earlier person, they're trying to put a force of friction forward. That's equal in magnitude to the force of friction they had before. So here's our x direction. But the drag force will be much, much larger than this if they're at this speed. So drag force at 268.8 kilometers per hour. So what we're asked to find is how many times larger would the drag force be acting on him than the frictional force on his tires. So drag at 268, and of course he'll have a normal force and a weight. 0.8 divided by the frictional force is what we want to find. Now our frictional force is equal to the drag on the other cyclist, drag on 71.3 kilometers per hour. And we're told that each of these drag forces is a constant times the speed, 268.8 in this case, squared. And those constants will cancel out. from proportional reasoning, we cancel out the constants, and then we're left with the square, in this case, of the speed divided by the square of the other speed. So we bring in our calculator at this point to 268.8 divided by 71.3 equals, and we square that to get 14.2. So we look at our answers. The only one that's anywhere close to 14 is C. So if the drag force is going to be 14 times greater than this person can pedal at, this person is going to be in serious trouble if they ever get out of that airfoil. When you look up this world record, you'll note that there's an elastic band that actually tied the bicycle very loosely. It was a loose elastic band, so he was pedaling on the bicycle, and there was an elastic band just in case he stopped pedaling. That would stop this airfoil from getting separated from him. So here's a car going quickly in front of him, and a loose elastic band as this person's pedaling